At 1,280 feet below sea level, where the pressure would crush ordinary structures, Norwegian engineers are building what will be the world's deepest submerged tunnel. The Rogfast is not just an impressive technical feat, it is a revolution that will completely transform how people travel on Norway's west coast. We will show you how this colossal engineering project is being built, the technical challenges overcome, and the impact it will have on the lives of millions of people. Prepare to dive into the depths of modern engineering and discover what makes Rogfast one of the most ambitious works ever undertaken by humans. Imagine driving comfortably at 1,280 feet below sea level, while waves and ships pass over your head. This dream that seemed impossible is becoming reality in Western Norway, where the Rogfast tunnel is being built. When completed in 2033, it will be not only the longest road tunnel in the world, with an impressive 17 miles in length, but also the deepest, reaching almost 1,312 feet below sea level at its lowest point. To understand the magnitude of this project, think about this. The maximum depth of the tunnel is equivalent to the height of a 130-story building, or approximately the height of the Eiffel Tower stacked on top of itself. The water pressure at that depth would be enough to crush a common submarine. However, Norwegian engineers have found ways to overcome this and other seemingly insurmountable obstacles. The Rogfast project, officially designated Rogaland Fixed Link, did not come about by chance. Norway is a country with challenging geography. With its coastline cut by deep fjords and hundreds of islands, travel between important cities often depends on ferries, which are slow and vulnerable to weather conditions. Currently, traveling between the cities of Stavanger and Bergen requires a long journey that includes ferry crossings, totaling approximately 7 hours of travel. With Rogfast, this time will be reduced to just over 4 hours, saving about 40 minutes on the tunnel section alone. But before we dive into the technical details, let us understand why Norway decided to build such a deep tunnel instead of other alternatives. Number 1, extreme weather conditions. The construction of bridges in this region would face strong winds and frequent storms. Number 2, intense maritime traffic. The Bokna Fjord, under which the tunnel passes, is a crucial navigation route that cannot be obstructed. Number 3, long-term economy. Although the initial cost is high, approximately 2 billion euros, the elimination of ferries represents significant savings over the decades. Number 4, national experience. Norway already has about 40 underwater tunnels, developing unique expertise in this type of construction. Rogfast is part of a much larger plan to transform Norwegian infrastructure. It integrates the ambitious renovation of the E39 highway, which connects the south of the country to the north along the Atlantic coast. Currently, traveling the 684 miles of the E39 between the cities of Kristiansand and Trondheim takes approximately 21 hours and requires 7 ferry crossings. When all sections of the renovation are completed, this time will be reduced to approximately 11 hours, without the need for ferries. One of the most fascinating features of the Rogfast tunnel is its internal configuration. Unlike some tunnels that have only one tube with traffic in both directions, Rogfast will have 2 parallel tubes, each with 2 lanes, ensuring greater safety and traffic flow. Every 820 feet, there will be passages connecting the 2 tubes, allowing quick evacuation in case of emergency. If a truck or vehicle catches fire in one of the tubes, drivers can seek emergency doors and cross safely to the other tube. One of the biggest challenges faced by Rogfast engineers is the presence of water. In deep tunnels, water infiltration is constant and can seriously compromise the integrity of the structure. To combat this, the team implemented a sophisticated drainage and waterproofing system. Drains are installed to capture water that penetrates through cracks in the rock, directing it to channels that pump it out of the tunnel. Additionally, a waterproof membrane is installed between the primary and final lining, ensuring that the interior of the tunnel remains dry. Another crucial aspect in the Rogfast project is the ventilation system. In such a long tunnel, ensuring fresh air and removing toxic gases from vehicle exhaust is vital. The Rogfast ventilation system will use enormous fans installed in vertical shafts and at the tunnel entrances. These will create a continuous airflow, completely renewing the air inside the tunnel every few minutes. Sensors distributed along the tunnel will constantly monitor air quality, automatically adjusting fan speed as necessary. Continuous monitoring is not restricted only to air quality. The entire tunnel will be equipped with a sensor system that will monitor various parameters, from rock stability to temperature and the presence of flammable gases. High-definition cameras will cover every meter of the tunnel, allowing operators in a control center to quickly identify any problem. And since we are talking about a crucial route for the region, the tunnel will be equipped with a redundant communication system, ensuring that it never becomes isolated in case of failure in one of the systems. Unlike conventional tunnels built in urban areas, Rogfast is being excavated from both ends simultaneously. On the north side, about 65% of the tunnel has already been excavated, while on the south side in Randaberg, approximately 45% is complete. Simultaneous excavation from both sides significantly accelerates the construction process, although it requires millimeter precision to ensure that the two sections meet perfectly in the middle. One of the most impressive aspects of the Rogfast project is that it includes a connection to the small island of Kvitsøy, the smallest municipality in Norway. This branch from the main tunnel contains two roundabouts excavated at 853 feet deep, allowing drivers to access the island or continue their journey through the main tunnel. These underground roundabouts are considered a significant innovation in tunnel engineering, possibly being the first of their kind built at such depth. Although the main focus of Rogfast is to improve mobility, the project also brings considerable environmental benefits. Firstly, the elimination of ferries will significantly reduce the carbon emissions associated with crossings. Additionally, all rock material extracted during excavation, estimated at millions of tons, is being reused in other construction projects, such as road bases and landfills. This zero-waste approach minimizes the environmental impact of construction. But when we talk about a project as ambitious as Rogfast, we cannot ignore its cost. With an estimated investment of 25 billion Norwegian kroner, approximately 2 billion euros, it is one of the most expensive infrastructure works in Norway's history. However, the Norwegian government considers this investment justified by the economic and social benefits that the tunnel will bring. To finance the project, the government will cover about 40% of the costs, while the rest will be recovered through tolls, estimated at about 230 reais per vehicle. The impact of Rogfast on the local economy will be profound. The faster connection between Stavanger, a center of the North Sea oil industry, and Bergen, an important fishing and oil hub, will significantly stimulate trade and industry in the region. As one of the project managers explained, it will help seafood and fish producers reach the market faster without the need to use ferries. Additionally, the tunnel is expected to boost tourism on Norway's west coast, already a highly sought-after area by international tourists. It is estimated that, by 2053, approximately 13,000 vehicles will use the tunnel daily, making it one of the most important routes in the country. But Rogfast is not just a national achievement for Norway. It is a milestone in world engineering that is redefining what is possible in tunnel construction. The technical innovations developed for this project will certainly influence future underwater tunnels around the world. When we think about the history of tunnels, we realize how drastically we have evolved in just a few decades. The first modern underwater tunnel was built under the Thames River in London in 1825, using a revolutionary technique for the time that involved a protective metal shield. Since then, constant advances in materials, excavation techniques, and monitoring have completely transformed what we are capable of building. The Seikan Tunnel in Japan, which connects the islands of Honshu and Hokkaido, held for a long time the record for the deepest submarine railway tunnel, reaching 787 feet below sea level. The Eurotunnel connecting France and the United Kingdom impresses with its 31 miles in length, of which 24 miles are under the English Channel. The most recent competitor, the Marmaray Tunnel in Turkey, is the first to connect two continents, linking the European and Asian parts of Istanbul. However, with its 1,280 feet of depth, Rogfast will surpass all of these, establishing a new benchmark in tunnel engineering. While Rogfast advances in its construction, other ambitious projects are being planned around the world. China, for example, has plans for a submerged tunnel of 76 miles connecting the cities of Dalian and Yantai, crossing the Bohai Strait. If built, it would be the longest underwater tunnel in the world, significantly surpassing Rogfast. Meanwhile, the Fehmarn Belt tunnel between Germany and Denmark, which will be the longest immersed tunnel in the world when completed in 2029, will use a completely different approach, with prefabricated elements submerged and connected under the Baltic Sea. The diversity of approaches in underwater tunnel construction demonstrates that there is no single solution for all scenarios. Each project needs to consider its geological, hydrological, and logistical particularities. In the case of Rogfast, the decision to excavate directly into the rock instead of using prefabricated elements was based on the exceptionally good quality of Norwegian rock and local experience with this type of construction. We can say that we are living in a true golden age of tunnel engineering. With advances in materials, excavation methods, and monitoring technologies, projects that would be unimaginable a few decades ago are now becoming reality. And Rogfast represents the pinnacle of this evolution, challenging limits and establishing new standards for what is possible to build. When completed in 2033, the Rogfast tunnel will not only be a link between two regions of Norway, but a symbol of human ingenuity and our ability to overcome seemingly insurmountable obstacles. This colossal underwater tunnel will demonstrate that, with proper planning, technical innovation, and the courage to dream big, we can literally move mountains and cross oceans. If you like this video about one of the greatest feats of modern engineering, activate the notification bell to be informed when we publish new content about other impressive projects around the world. Leave in the comments which other engineering mega projects you would like to learn about in detail. Your opinion is important to us and helps define our next topics. Thank you for watching and see you in the next video.